Hi again, everybody. This is Kyle Cordes again at Oasis Digital with the fourth in my series of videos where I am exploring some example code that I wrote as I was trying to understand the merits of Cycle.js. As a reminder, you can see here the repository URL if you want to follow along in the code. And then I've already run over here, I've run an npm start and an npm install, npm start. And so right here I have the application running. Now, we most recently in the previous video we looked through how this search feature works, and I would definitely encourage anybody just stepping in now to go start back at video number 1. There should be some kind of playlist or something you can find here on YouTube. For this video we're going to look at this counter application. I'm going to explain this to hit two things. First, we're going to see another example of a tiny little application that has a bit of state, a tiny little component, and then we're going to see something about composing components. So for the moment, you can disregard almost the entire screen and look only at one individual counter that I'm sort of moving my mouse around right here. You see it has an initial value of 0, and then I can click this increase button to go up and a decrease button to go down. So this is I believe there's a lower limit of 0, there's no upper limit, so this is pretty close to the sort of simplest reasonable stateful component, and we're going to go look at and understand how that is implemented. So getting oriented in the source code, I've done this thing where I number the directories that contain the code to keep them in the order of complexity that I want to talk about them, but these are just names. I've just used these funky, unusual names that have numbers on them. These don't matter at all to Cycle or to TypeScript or to anything else. I'm probably going to skip this modal summary, this modal summary thing, and only talk about my individual counter and my set of counters. So let's look at an individual counter. Okay, so standard reminder, this is Cycle. So a component is just a function that takes some sources and returns some sinks. You can look back at the last 3 videos to hear that said probably 8 more times. This particular function, its counters are only the DOM and then something called the onion. Now, I don't think we've seen onion before. Onion is it's a colorful name for the state management system, which is hopefully on its way to becoming a off-the-shelf part of Cycle. Right now it's not quite in the main Cycle box. If you look at its import path here, it's not at Cycle anything, it's just cycle-onionify, but this is from Andre. So this is closely connected to the rest of Cycle in terms of authorship. It's just not in the box quite yet. Furthermore, I'm actually working on a release candidate version of it. I'm hoping that maybe, I don't know, version 4 or 5, somewhere in there, it'll become more officially part of the rest of the Cycle core. The important thing about it is to simply ignore the word onion for now and think of it as if it was named, the Cycle state management mechanism. So this is a mechanism to manage state in Cycle components and applications. Now, the state we're managing here for an individual instance of this component is just a single number. So I've made an interface to define the structure of that state. I've said that consists of one number called count. Then I've used this to parameterize what sort of state I'm going to be able to get from this onion mechanism, and we'll see how I get the mechanism, or I have to say the word onion to get it, but you can sort of disregard the onionness for the purpose of working inside this single component. Okay. As usual, my component returns primarily a DOM, so this returns something that it's a stream of virtual DOM that will control the appearance of this component on the screen. And I have found it, as usual, easiest to explain the view function that defines the appearance first. So the view function takes a stream of states. So this is a state, so it's going to receive one of these, then another one of these, another one of these, and so on, and it's supposed to return a stream of virtual DOM. So each time that counter changes, it's going to regenerate its appearance with, I guess, a new number in it. Okay. I only care in here about the count, so I've simply said map s to s point count. I could have skipped this map, and then down in here instead of count I would have said s point count, but just for to kind of demonstrate that all the normal stream stuff is available, I went ahead and did an extra mapping in here. Next, I don't recall if I've done TSX before this. Looks like I did a little bit of TSX. So this TSX works exactly the same, or almost exactly the same, as you might have seen in React, except here it's working with SnapDOM, not with ReactDOM. But it works the same way, and it lets you use a very HTML-like syntax to define the view. So my view for this consists of one div. It has a paragraph that has the word counter and then some number. Then it has a couple of buttons. This pure thing, this is just for that pure CSS library I'm using for appearance, but this add, this is a hook I'm going to use so that when I recognize these clicks, I can grab the specific button for add and subtract. And that's a cycle pattern, at least for now with SnapDOM. It's a cycle pattern that you put some kind of marker, like an ID or a class or something, for the things that you want to recognize events coming through in your component code. So one number appears on the screen, you got an add and a subtract. Very simple view. Let me see here. There's this intent idea, and you can read it in the documentation. It's a thing called model view intent. It's not yet clear to me that this intent notion is widely applicable, or if it's only helpful for certain kind of situations. So we're just going to ignore the word intent mostly, and instead just kind of talk through how this thing really works. So the way Onion works is you receive a series of states as you input your component, and you supply on the output a series or a stream, whatever, of reducers. A reducer is just a function that takes one state, returns a different state. So the interesting thing here is that means that this component never actually changes its state. It just receives some state, and then it emits functions which, if executed, will change the state or will produce a new state, and it relies on some other code to do that. Now that other code is part of this cycle unify mechanism. We don't really care how that works on the inside. Let's just see what happens here. We have a default reducer. So this is going to come in handy to get an initial state to work for this thing. And this is a pattern that you follow with, well, Onion especially, but even more broadly with Cycle, is that it's possible that you might have some state supplied by the outside world. So a component that has a number like this, there may be some mechanism where a broader component or an application that uses this component might want to supply the number, but it might not. So you need to work either way. So the default reducer is an observable stream, right? And the type is reducer. So default reducer $, this means a stream of reducers, and it's the default stream. Now xs.of, this actually means that this stream is just going to consist of one reducer. So while it is technically a stream, this stream is always of length 1. Now the thing that this is a stream of, or the type, is of type reducer. Reducer is a function that returns a state, or takes a state and returns a new state. And I've defined that function this way. So if the thing passed in is anything truthy, such as, say, an object, right? So really any instance of this at all would be truthy here. So by default, it'll simply take the state that arrived from the outside world. But if not, so with the OR operator, we'll get a state where the initial count is 0. Now this is reasonably nicely typed. Like, you just type a number there. I should be able to get some sort of error out of it. I guess I don't have things configured correctly. But it's reasonably nicely typed because this has to be a stream of reducers. Reducer is typed to be this function to this function, and then the input and output of that function are defined up here. Now, if we could only get the initial value, this wouldn't be a very exciting component because it would never change. It would be like some of the earlier components we looked at, and we're trying to look at a more realistic component. So there are two kinds of things that happen. So I've defined two streams of those things that happen. So add and subtract. Now we've seen this syntax before. The way you get a hold of events coming in off of the DOM, or you take this DOM source, so that's arriving this way, and you call select with a CSS-like selector. So I've said find anything that has an add class, so I'm getting that button, and then listen for any clicks. And then if those clicks happen, I want to turn those into something. Now, if you've worked with any kind of observable library, you've probably worked with the map function extensively. There's a simpler form in Xstream called map2, which is used for cases where you don't actually care or use the incoming value. You just want to say whenever any value at all arrives at this point in the code, then the stream should emit one of these, whatever's inside these parentheses. Now this is a reducer, so the thing it emits is simply a thing that takes the existing state and it returns a new thing. Now I have some slightly arduous TypeScript syntax here, so if I was missing that parenthesis, then this opening curly brace would be interpreted as a code block. But with the parenthesis, everything after the arrow is instead interpreted as an expression, and this expression consists of one object literal. So this is saying the existing object existing state, which is an object, will come in, and an object will come out, and that the shape of the thing that comes out is this. Now, this is the object spread operator. So I've said take everything that's part of the state and start with that. Now, it so happens the only thing that could be there is count. So this code right here doesn't do anything at all in this example code, but this is a really good pattern for implementing these reducers in general, so I kept this in here. So this says take the existing state and then supplement it or augment it or update it with this additional field. And this field will overwrite a count field if it's already in the state. So what this means is whenever an add button is clicked, then emit a reducer which takes the current state and produces a new state with one bigger number. Now subtract works almost exactly the same way. Whenever the subtract button is clicked, emit a reducer which takes the state and emits a new state with one smaller of a number. But I didn't want to let somebody accidentally, or I guess or intentionally, go below 0, so I used a max function here. I said if it's the state.count -1, but it's the max of that in 0, so if this were to ever fall below 0, the value would be 0. The interesting bit here is that, in a sense, this logic that implements the max or implements that lower bound, it's not actually executed here, right? Because this just returns a function. In fact, it returns the same function every time it emits the same function. So when some other code runs that function, that's when that actual lower bound is enforced. And again, that's actually going to happen down inside this onionify that I'm not going to go in the insides of. I now have these 3 separate observable streams of things that can happen to the state. So there's a thing that always happens at the beginning, then there's additional things that can happen. Well, I need one stream, right? Because the API that I described is that you return a sync, it's called, which is a single stream of changes that should happen to the state, or reducers that will affect changes to the state. So I use the merge operation in Xstream. So it just says sort of append together and combined all 3 of these observable streams. So at this point, the thing coming out right here, so the thing coming out right here is going to initially, or it's going to be a stream of functions, right? Because that's the type of functions. And the first function is going to either take the state if it exists and leave it alone, or make it a 0. And then there'll be these additional functions coming down the pipe that can increase or decrease the value of the counter. Now, I've now explained all the code, I think, for what goes on inside a single counter. So if that didn't make sense, I'd kind of recommend actually maybe go back to video 1 and rewatch, and then maybe rewatch this video from the beginning, because it's going to get a little bit more complex now. So I mentioned onionify, that's where it's going to get more complex. So onionify provides machinery that makes it easy to have multiple instances of components without them stepping on each other's state. So now let's look at the code for this overall portion of the screen that I'm gesturing around right here. So it has 2 counters. I won't explain this part. This has 2 counters, and you'll note that they operate independently. So let's look at how those counters' state is separated. Okay, so starting at the beginning here, we have sort of pretty typical code. Here, I can even shorten it a little bit as I work on it. The key parts we're going to want to study are these two, so I'm going to actually separate those out with a comment used for isolated per component state, so that way somebody looking at a future version of the repo will have a slightly easier look. Now, here is the component I just wrote being imported into this component. So again, this is cycle. A component is just a function. So I didn't need to do any cycle things to import the component. I just imported it in a TypeScript, JavaScript sort of way. This set of sources that this component, that this counters component, so that's this thing. This likewise is a set of sources, and it's in fact the exact same sources. And I haven't bothered to type the onion state thing this time because I actually don't care. Inside this broader component, the details of what state might exist for components inside of it are completely irrelevant. I mostly wanted to demonstrate these lines right here. So this is an oddity of cycle, or perhaps a consequence of the elegance of cycle, where components are just functions that do sources, take sources and return sinks. And that is that when you use a component, it's not automatically isolated. If you just sort of use it without doing all this isolate stuff, basically the state and implementation of the inner component would get mixed in with the component you're using it from, right? It would just be essentially it would just be a function call. If you want it to be isolated and be able to use that state mechanism without the states mixing, then you have to do this isolate call. And by the way, that also provides isolation of the button clicks to make sure that this button click is not registered as a button click over here. Okay, so to get my counter, I do isolate. So isolate is it's a higher order function. So you give it a function, it returns a new function. You give it a component, it returns an isolated version of that component. And then of course to use a component inside another component in cycle, you simply call that inner component. So here's the inner component, here's the wrapped inner component. I call that passing along my sources. Do that twice for my two counters. And I'm going to skip the modal because it's kind of noise relative to the main point here. Now, my sinks are about the same. To define the appearance, right? So the appearance of the overall component, well, it's going to need to include the appearance of the subcomponents. So I've had to pass that DOM apart. So I have to pass these streams of the appearance of the subcomponents into my view function. Now you might think of this as being, this is either a rough edge of cycle or it's a feature of cycle. I'm not quite sure which. And that is that there's really no way to just use a component at a single point in the code. Inevitably, you are making the component and then you're sort of passing wiring to it in multiple directions. So here I'm making this counter, it receives incoming wiring, and then its wiring goes out one direction, one of its DOM goes out to make the right appearance, and then this onion thing, which I described as it's a state management library, I have to pass its reducers, so its functions that manage state, those have to be sent out via a different pipeline. So this one counter kind of has one incoming set of pipelines and then two outgoing pipelines. That initially seems a little bit frustrating if you might have used other libraries where you can kind of use a subcomponent trivially and that like it just does the right thing and the state just gets wired up. But there's some really powerful things you can do because of this. So for now I'm sort of neutral on whether it's better or worse to have to write these couple of extra characters to use a subcomponent in an isolated way. Okay, so let's talk through what's actually happening. We'll talk about the merge first. This is simply a way of saying that so onion, which is a stream of reducers, so a stream of things that change the state. Well, the way you can change the state for the overall component is simply by changing the state of something inside it. And so the set of operations, or the stream of operations to change the state of the overall subsystem is simply the result of merging those changes that come through the subcomponent. So managing kind of bringing the state change together, that's that one line of code. The view is, of course, a little more to explain, a little more code here, but we just know that we need to have the appearance of these two subcounters to display the overall counter. So this is now just fairly boring templating with a couple of slightly interesting TypeScriptisms. So X stream combines. This is a way of saying consume two streams, but whenever either one emits, go ahead and emit both downstream in my observable chain. So if one or both of these emits, then the observable right here will emit. The thing it will emit is an array that contains the values of these two things, and so I will then do a map. So inside the map, this is the appearance of counter 1, this is the appearance of counter 2. So I could, if I wanted to, I could give these, this is actually the DOM of that, so I could give them names that maybe make it a little bit more self-explanatory, but that's all that's going on. So this is the same kind of TSX or JSX we just saw. Then at the point you want to use a subcomponent, there's no special syntax to use the subcomponent. It's just virtual DOM, and we have the virtual DOM right here, so we just use the TSX syntax to put that virtual DOM in. And there's really no cyclisms anywhere in here. Okay, so looking at my time, we're at 21 minutes, so I don't think I'm going to go on to the next step in this video, but I do appreciate anyone watching. I encourage you to click the subscribe button down there wherever it is, and keep an eye out for my next video, because I will go forward with the next bit of code there. Take it easy, and bye-bye.